Okay, so this week we're covering section 7.3, and we're using our techniques for counting, combinations, permutations to compute basic probability. So I'm going to go through a couple of practice problems. I uploaded a file on Blackboard that has the problems that I'm going to go through, so you should probably have that open because I'm not going to write out everything for every problem. So looking at the first one, it says let event E be the sum of a pair of dice that is greater than or equal to 8. So E is the event if I take two dice, roll them, and then add up the numbers that are on them. So think about all the numbers that are on a die. We have 1 through 6. So number 1. And so we have 2 of these dice. So the smallest sum I could have is 1 plus 1, that gives me 2. And the largest I could have would be 6 plus 6, which gives me 12. So all the numbers, 2, 3, all the way to 12. These are all the possible sums. And we know that event E is equal to the set of all the sums that are greater than or equal to 8. So E is 8, 9, 10, 11, 12. And this problem is asking us to list out E complement. So E complement, we've talked about complements with sets before. So our universal set is right here, 2 through 12. We know E is 8 through 12, so E complement must be all the other numbers. So E complement is going to be 2 through 7. So 2, 3, 4, 5, 6, and 7. Alright, so the next problem we have says Logan and James have a jelly bean collection. Together they have 38 flavors. So we got 38 flavors of jelly beans. It says if they decide to randomly choose 2 flavors, what is the probability that the 2 they choose will consist of each of their favorite flavors? So here we're computing basic probability. So remember from last week, probability is going to be in the form of a fraction. The bottom is going to be kind of like your universal set, the total amount that you could have. And the top is going to be the very pointed, exactly the event that's going on. So on the top, we're talking about we choose 2 jelly beans, and we want to know what is the probability that the 2 jelly beans consist of their favorite flavors. Well, there's only one way that can happen. We get both their flavors or we don't. So the top is automatically 1. And so the bottom is going to be overall what's going on. I have 38 flavors of jelly beans. How many am I picking? I'm picking 2. So the question here is, does that order matter? Does it matter if I pick blueberry and then strawberry or strawberry and then blueberry? The answer is no, I just need to get them. So since order doesn't matter, we're going to have a combination. So on the bottom, I have 38 flavors and I'm going to choose 2. Again, using a combination because the order doesn't matter. You can plug that into the formula. There's plenty of calculators online, or if you have a graphing calculator to do the combinations, that is great as long as we can do them. So in the calculator, 38 choose 2 is 703, so we get 1 over 703. So the probability of them choosing 2 random jelly beans and both those jelly beans consisting of both of their favorite flavors is 1 out of 703. Alright, next problem. So here's another complement problem. We have a chart that's age of volleyball players, and I think the words are cut off, but it says something to the effect of set A or event A is the players being age greater than 9. And we want a complement. So we're given a chart. I'll go ahead and write it up here so it makes sense. We are given a chart. It's got 2 columns. We got age and number of players. So their age range is 7 to 10. So event A is that we have the players that are their age is greater than 9. So if you think about who falls into that category, who is in that event, greater than 9 would be 10 years of age according to our chart. So there's only 7 of them. So it wants to know how many are in A complement. Well, A complement, if A is greater than 9, then A complement would have to be less than or equal to 9. So we're talking about all of these people right here. So I have, write that out, less than or equal to 9. So that's 4 plus 3 plus 5, which gives me 12 players are in that event or in that category. All right, so the next problem is talking about a passcode. I think this is the sneaky spy. Yeah. So it says Avery sets up a passcode on her tablet, which allows only 9-digit codes. Get that set up. Okay. A spy sneaks a look at Avery's tablet and sees her fingerprints on the screen over 9 numbers. What's the probability the spy is able to unlock the tablet on his first try? All right, so here again is a probability problem. I think this is number 4, ... question mark? Yeah, number 4. All right, so here again is a probability problem, so it is going to be a fraction. On the bottom, this is our overall probability. So big picture, what is going on? It's a 9-digit passcode, and we got to choose 9 numbers. So does the order matter here? So if I have, let's make it small, a 2-digit passcode. Say my passcode is 12. If order didn't matter, then your passcode of 21 could unlock my phone. So we don't want that to happen. So definitely order is going to matter as far as passcodes go. So we are going to look at a permutation, not a combination. So there's 9 numbers to choose from, and we need to order all 9 of them. Order mattering, so this is going to be a permutation. So we have 9 permute 9. Now on the top, this is the actual event we're talking about, him guessing her passcode on the first try. So out of all these numbers that we're going to look at in just a second, how many of them are the correct passcode? And the answer should be 1. There's only one way that he can get the correct passcode. It's by getting the correct passcode. So we have 1 over 9 permute, that's a P, how about a 9? 9 permute 9. There we go. And 9 permute 9, again, plenty of calculators online or a graphing calculator, or you just simply using the formula, you should come up with 362,880. So the probability that the sneaky spy gets her password on the first try is 1 out of 362,880 times. So he's got to be really freaking lucky. All right. Number 5 says there are 4 sets of balls, number 1 through 10, placed in a bowl. If 4 balls are randomly chosen without replacement, find the probability that the balls have the same number. Express your answer as a fraction, lowest terms, or a decimal rounded to the nearest millionth. So again, we're looking at a probability, so our answer will be in the form of a fraction. And so we have 4 sets of balls, 1 through 10, placed in a bowl. So I have 1 set of balls, 1 through 10, and then another one, 1 through 10, and another one, 1 through 10, another one, 1 through 10. So 4 sets of balls, and we are going to randomly pull 4 of them without replacement. And we want to know what's the probability that they're all the same number. So on the bottom, this is our overall picture. What is going on? How many total balls are there? There's 40. How many am I picking? 4. So the question is this a combination or a permutation? Does the order matter? Well, since we're looking at the probability of getting the same number, it doesn't matter the order I choose them in, because it's going to be 1111 or 7777, right? So the order there doesn't matter. So big picture, order doesn't matter, so it's going to be a combination. So I'm taking the 40 balls, because I had 4 sets of 10, and I'm doing a combination of 4. And again, calculator, internet formula, whatever you want to use. 40 choose 4 is going to end up being 91,390. Now the top, this is actually taking those 4 balls and what's the how many ways could all 4 of them be the same? Again, order is not going to matter because we're talking about them all being the same. So one way that we could look at this is if I take 4 balls and I'm choosing 4, right? That's what's happening here. I'm gonna pick 4 and I need to order all 4 of them. But order doesn't matter, so I am going to use a combination. So this is what it looks like for all 4 that we're choosing to be the same number, right? I want them all to consist of the same number. So this is 4 choose 4. Again, order doesn't matter. Now this would be if they were all 1s, or all 2s, or all 3s, all 4s, so on and so forth. So how many different options do we have of this? And the answer is 10, because the balls are numbered 1 through 10. So 4 choose 4, again, you can put this in your calculator, or just use the formula. You're going to come out with there's only one way that this could happen. But again, this just talks about one situation, this being the 1s, the 2s, the 3s, so on and so forth. Since they're numbered 1 through 10, there's 10 ways that this particular situation could happen. So 4 choose 4 is 1, so I'm going to have 10 times 1, which is 10, and this fraction can be reduced. So I get 1 over 9139. All right, so the next problem says a committee of 4 is being formed randomly from employees at a school. We have 4 administrators, 32 teachers, and 4 staff members. What's the probability that all 4 members are teachers? All right, so again, probability. So I'm going to have a fraction. So big picture here, we're picking 4 people to be on a committee. Out of how many? There's 4 admin, 32 teachers, and 4 staff. So 4 plus 4 plus 32 gives me 40. So out of 40 people, I'm going to pick 4 of them. And this is just for a random committee. So it's not like when they get on the committee, they have a special job or anything like that. So if I pick them, they're on the committee. So the order I pick them in does not matter. So this again is going to be a combination. And look, we just did that in the previous problem. So I know the bottom is going to be 91390. Super fancy. All right, so the top, this is the actual event. So I want to know what's the probability that all 4 of them are going to be teachers. So my event is picking teachers. How many teachers do I have? I have 32, and I want to know how many different ways can I choose 4 of them. So again, combination, because if I pick you, I picked you. You're on the committee, it doesn't matter the order. So I have 32 choose 4 over 40 choose 4. We already said the 40 choose 4 was 91,390. If I have 32 teachers, I can choose 4 in 35,960 ways. This simplifies to 3,596 over 9,139. So that's the probability of if I choose 4 committee members out of the 40 that all 4 will be teachers. All right, next problem. I think this is the pizza problem. Let's go see. Yeah, so a local pizza parlor has the following list of toppings available for selection. The parlor's running a special to encourage patrons to try new combinations of toppings. See. They list all possible 3-topping pizzas on individual cards and give away a free pizza every hour to a lucky winner. Find the probability that the first winner randomly selects the card of the pizza topped with olives, sausage, and tomatoes. Express your answer as a fraction, blah, 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 blah. Okay, so again, we're finding probability, so I know this is going to be a fraction. So bottom, big picture. I need to see how many ways I can pick 3 toppings out of, you got to count them up. There are 15 toppings total. So I got 15 toppings. I want to choose 3 of them. Do I need a combination or a permutation? Some people would debate this, but in all honesty, it doesn't matter if you put the olives and then the pepperoni, or the pepperoni and then the olives. You still have those toppings on the pizza. So order here does not matter. So big picture, I have 15 toppings, and I'm using a combination to choose 3. The event that's going on is that I have olives, sausage, and Roma tomatoes. So how many pizzas can I make with those 3 toppings that have all 3 toppings? So this is 3 choose 3, which is just going to be 1. Right, and you could do the formula for that, but how many pizzas can I make with those 3 toppings? If all 3 toppings have to be on the pizza, the answer is 1. So 15 choose 3 is going to give me 455. Again, you can use an online calculator or plug it into the formula. That fraction is reduced. All right, next problem. It's number 8. It says find the probability of choosing a letter other than the letter E from a bag that contains 15 letters of the name Ernest Hemingway. Express your answer as a reduced fraction or a decimal round to the nearest millionth. So Ernest Hemingway, it already tells you there's 15 letters, and you want to know the probability that if you randomly picked one letter out of a bag that has all those letters, the probability you'll get a letter other than E. So we don't have to use any combinations or permutations or anything like that. We already know there's 15 letters. I can count up. In Ernest Hemingway, there are 3 E's. So how many other letters does that leave? The answer is 12, right? So there's 12 other letters. This is essentially a complement, 12 other letters out of the 15. So if I reduce that, top and bottom are both divisible by 3, so I get 4/5. So the probability that if all the letters in Ernest Hemingway's name were stuck into a bag, the probability I would choose a letter other than E would be 4/5. Alright, almost done. So looking at number 9, says it's presentation day in class and your instructor is drawing names from a hat to determine the order of presentations. So that's a key word right there, order of presentations. So probably could figure out right now we're going to have to use some sort of permutation. So if there are 18 students in the class, what is the probability that the first 2 presentations will be Kelly and Harmony in that specific order? So again, we are looking at probability, so I know my answer is going to be a fraction. So the key event here is that Kelly and then Harmony are presenting first. So that order is already decided. How many ways could that event occur? The answer is 1, because there's Kelly and then there's Harmony. There's no other way that that could happen. We could do some permutations and things to figure it out, but it's already there for us. There's only one way that that could happen. You pick Kelly and then you pick Harmony. All right, so big picture, I have 18 students. We're picking 2 of them, and obviously since we're looking at the order of presentations, order matters, so we need a permutation. So we're doing 18 permute 2. I lost my paper. Yeah, 18 permute 2. So again, formula, calculator, internet, what is 18 permute 2? The answer is 306. So we get 1/306. Already in simplest form. Alright, so the last problem says there are 8 balls numbered 1 through 8, so another balls in a bucket problem. What is the probability of reaching into the bucket and randomly drawing 4 balls numbered 1, 4, 8, and 6 without replacement in that order? Express your answer as a fraction in lowest terms or a decimal rounded to the nearest millionth. So we'll call this number 10 real quick. So there's 8 balls numbered 1 through 8 in a bucket, and we want to know what's the probability that we get 1, 4, 8, and 6 if we draw 4 balls, and we want them in that order. So this is probability. So it is going to be in the form of fraction. In the top, we want 1, 4, 8, and 6 in that order. How many different ways can that occur? And just like the last problem, the answer is 1. Only one way could that occur. I get a 1, then a 4, then an 8, then a 6. So the big picture, what's happening here, we're just talking about the number on the ball that we draw. How many numbers are there? There are 8. How many are we drawing? 4. Does the order matter? Yes. The order that we're looking for is 1, 4, 8, and 6. So since order matters, we are using a permutation. So big picture, there's 8 numbers. We're looking at ordering 4 of them. So this is going to be a permutation. So the denominator is 8 permute 4, which is 1,680. So we have 1 over 1,680.